Hello, today we are going to learn how to debug KDE KCMs, which are KDE Control Center modules, so System Settings modules. So quick recap, this is how the KDE Control Center used to look like. The executable name was kcontrol, and this was replaced by the System Settings application. Okay, and the old name was kept for KCMs, which are now System Settings modules. Okay, so there's an application called KCM Shell. Let's see what this is about. Okay, so I'm on Kubuntu 22.10. It's available in /usr/bin/kcm shell 5. This is from my Linux distribution. And let's look at the help. List all possible modules. Okay, so these are all of the possible KCMs, System Settings modules, that can be open either in System Settings or in KCM Shell. And this example uses the KCM network management, KCM. So KCM Shell, and then the name of the KCM. And it opens just the System Settings module for network connections, network management. Okay, and there's help -all, which displays additional command line options for the KCM Shell 5 executable. So in addition, there are GUI options such as geometry, platform, icon, RTL, to use a non-default display. Okay, so it says KCM Shell, then some options, then the name of a KCM, a module. Okay, so I have built, using KDE-src-build, the KCM network management, which is part of Plasma NM. So let's go there. So this downloads or git clones a number of KDE Git repositories, including most of the KDE frameworks and Plasma Network Manager, and KCM Shell 5 is part of KDE-CLI-tools. Okay, so there's not much to build. I have just run this command line previously. So it's just making sure that the source code is up to date, that everything was compiled and then make installed correctly into ~kd/usr. Okay. Now we'll need to use a prefix. Any of the prefix files would do. All of the prefix files are identical, so we can source the prefix from ~kd/build/plasma-nm or any other one, such as ~kd/build/kconfig/prefix.sh. Okay. And now we have more than one KCM shell available in all of the directories that are part of the environment variable path. So there's one from ~kd/usr/bin and the other one from my Linux distribution in /usr/bin. Okay. This will actually exercise the KCM shell 5 from ~kd/usr because that's the first in path. And first, when you go which -a space KCM shell 5, using the KCM shell that I have built from ~kd/usr, I also open the KCM network management that I have just built using KDE-build. Okay, and we can make this, prove this thing by using lsoff. We go lsoff, and then we grep by KCM shell. Okay, we need to resize this window. So it uses Qt from /usr/lib, a ton of X and other libraries, compression, image formats from /usr/lib, but then all of the KDE libraries, all of the KDE frameworks are from ~kd/usr. Including the KDE frameworks and QML libraries. libk5 plasma quick SO. Okay, so the correct executable has been loaded, which is KCM shell. The correct KCM modules has been loaded from ~kd/usr. Okay. The next thing we're going to do is actually run in a debugger the KCM network management. So this screen recording is about how can we edit the source code of a KCM, such as KCM network management, how we can debug it, how we can make sure that our changes are correct. Okay. Let's close the KCM shell. Doesn't GDB work? Okay. So GDB --2e opens in a text user interface the source code, and it crashed because we don't have any arguments. Control D. Okay. So let's see in the IDE, Integrated Development Environment Qt Creator. Okay, where is Plasma NM? In SRC, Plasma NM, this thing. File, open file or project, Control V, CMake lists, clean up the kits. We keep just the one that's italic and name desktop default. And then we import the existing build where KDE SRC-build has run CMake configure. So in the same directory but with SRC replaced with build. Okay. At run, we need we have a mobile provider test, so there's tests, executables, but what we want to do is run the full GUI, the full KCM for network management inside of the KCM shell 5. Okay. Let's do what the wiki page says. So we need to find the KCM projects, KCM network management, source files, kcm.cpp. Let's find the main. Where is the entry point? Testing the constructor. Okay. So we go switch to projects mode, Control 5, this thing. Build and run, this thing. Imported kit run settings. Imported kit run. Run settings. Run configuration, add custom executable. This thing. Custom executable. Create. And executable. Do we have auto completion here? Yes. /kd/usr/bin/kcm shell. The name of the KCM as argument. Okay. Running terminal. And we want to have the correct environment variables. So while it's running, we need to have the environment variables set in a very similar way to what the prefix.sh file does. So KDE build kconfig prefix. These settings, these environment variables, need to also exist while KCM Shell 5 runs. So for that we have the wiki page of Qt Creator, and we need to copy this part, Ctrl N, Ctrl V, and replace username with my home directory name, so my Linux user's name. Ctrl R, tab, Ctrl V, replace all, Ctrl C, and in batch edit, Ctrl V, okay. This should be it. So the run environment where KCM Shell 5, when KCM Shell 5 runs, the same environment variables should exist as when make is run to build the project, but also the following environment variables need to be edited. So path should have this directory prepended, QML to import path should have this directory prepended, Qt plugin path should have this directory prepended, and 3 other environment variables should have these 3 directories prepended. Okay. When we went import existing build, it already has run the CMake configure step. Now we can just press the debug button, because that will also build automatically. Okay. Delete all breakpoints, yes, and put the breakpoint again in here. Okay. So we have continue F5, step over F10, step into F11, step out, shift F11. Let's stop the debugger. If we can. So GDB frontends and debugging in IDEs is not a scientific science. It's sometimes miss and match, hit and miss. Okay, let's run without debugger. Let's see if this thing works. Okay, it works. We don't really need the window. So projects run, don't run in a terminal. Let's start it again. Okay, and now let's run it with the debugger. Okay, and this time it worked correctly. Okay, so some things are optimized out, although I do not build with optimizations. Why is that? So I use as CMake build type debug in order not to have any optimizations when we build C++ source code. This way I can debug correctly, and when I press F10 to step over, it will not skip from line 61 to line 74 and then back to line 73 and then back to line 72, etc. So it will not jump all over the place. Functions will not be inlined, etc. So if you want a good debugger experience, you need to not optimize and you need to have debug symbols. So that means CMake build configuration debug with an uppercase D. Okay. So we can step into constructors because we have built all of the KDE Git repositories from scratch using debug build configuration, using KDE src-build. So we can step into anything. We can't not step into Qt things because I did not build Qt 5 using KDE src-build. I can step into .h files from the Qt framework, but that's not that important. Okay. Set translation domain is from where? From a KDE framework, so we can step there. Set translation domain. Okay, so we had the first breakpoint in the constructor of KCM network management class, and now we're inside the method set translation domain. You declare private. Okay, if not translation domain, then we use the new translation domain, which is Plasma Network Management KCM. Okay, set context object is from QML, so we cannot step there. Okay, so can we inspect use up node by hovering on top of it? Yes, we can. We can hover on top of found inactive. Found inactive is here in the locals tool window, and use up mode is this in the locals tool window. Wi-Fi device is null. Okay, it goes through the network interface cards. Only if it's wireless. So I have a wireless network interface card. Which is which? Yeah, it's active. AP mode means access point. Okay, so this should be it. We're inside GDB. GDB has a front end, which is the Qt creator. ID is debugger. We can inspect, step into, step out, do all of the usual debug things. Okay, so we have loaded in the ID in Qt creator the correct module, the one that we want to edit and make sure it's okay, which is the KCM. And then we're driving the KCM. So the KCM is building a .so file, a shared library, and we're driving that shared library using an external executable, which is KCM shell 5. Okay. So this allows us to edit the source code as we want. I know. Put breakpoints, stop the debugger, save, and then immediately start the debugger, because starting the debugger will automatically build, and it will not do a rebuild. It will do just a build. Will build just the kcm.cpp translation unit, so the rebuilding would be really fast. Okay, unused variable, but it has a value, which is what? Doesn't have any value. It looks like it's optimized out, which is strange. Why is that? We're using the correct debug configuration. Where is the KDE src-builderc? So it says cmake dcmake build type equals debug. Yeah, because the cmake ran a strange thing. So I need to stop the debugger and run cmake again. Let's look at what it did this time. So it's still incorrect, because it doesn't say that cmake build type equals debug. So it was initially cmake debug type, build type debug, but then I don't know. F5 to continue, which will jump to the next breakpoint. Okay. So we're doing the wrong thing. Okay, so that was it. So we're running KCM shell from ~kd/usr, but then we don't tell it which KCM to load. We tell it just a name of a KCM. And the name of that KCM is correct, so it will try to load the KCM from ~kd/usr, but the kcm.so file is not there. Okay. Where we actually build is in here. In the parent directory of the bin where we build, so this in here, there's a bin plasma KCM System Settings widgets KCM network management.so. So this is because it doesn't run the make install step. It doesn't know how to KCM shell 5 doesn't know how to open which .so file to open, like that. So how can we do that? Does KCM shell have a way of passing an SO file? Can pass it a desktop file. What if we go KCM shell and we give the full path to the .so file? So it's in plasma nm, then bin, then in here KCM, not that. This thing. Control Alt C, Control Shift V. Okay, it does not work. How about if we create a symlink from this file to the place where KCM shell finds its SO files by default? So let's go KCM shell, KCM network management. It's already running. Okay. In lsoff, we'll grep for /bin/KCM shell, this thing. No, we need to grep by the SO file name, so by this thing. Control Shift V. So this thing, copy. So this thing needs to point towards this thing. Hopefully it's enough. Okay, so that should be ln minus s, this thing, and the symlink. So this is a file that actually exists on the hard disk, and this file needs to be the symlink. Okay. rm this thing, close this thing. The KCM shell now should fail. No. What does it do? Oh, I deleted the wrong file. rm minus rf. This file, and this should be reversed. This file is in tilde/kd/build and exists. This file does not exist and is in tilde/kd/usr. And we're deleting the one from tilde/kd/usr right now. Okay, it fails to load. And now it loads successfully. Okay, let's run this thing in the debugger then. F5. So A exists and has the value 1. And if we had the output console terminal, we could have seen the echo 1. Okay, so that was the problem, because Qt Creator does not run make install. Qt Creator does never write files to tilde/kd/usr, and KCM shell 5 was only loading files from tilde/kd/usr. So KCM shell 5 is from tilde/kd/usr/bin, and it looked for all of the files in tilde/kd/usr. So that's one way to do it. We build using Qt Creator, and Qt Creator builds files here in tilde/kd/build, and then from here we make a symlink to the tilde/kd/usr/lib/ where that thing is. In here. This thing. Okay, so KCM shell will know how to load this file, but this file is just a symlink that in fact is the file that has been built by Qt Creator. And now we're inside the Qt Creator, inside the debugger, and we have a fast edit, build, running debugger, development loop. So this was it. Thank you.